Well, hello and good morning. I hope everyone can hear me. We're going to start the webinar now, MRDCL 5 Big Productivity Tips. I've got Phil Hearn here with me. He's going to take you through 5 or 6 techniques to improve your productivity and efficient use of MRDCL. There'll be a Q&A box where you can type in questions throughout, and we'll stop after 4 different sections and answer your questions as we go along after each section. So what I'll do is I'll pass over to Phil now, who will start the webinar.
Okay, well, good morning, everybody who's on this side of the world, and good afternoon to anybody on the eastern side of the world. Apologies, first of all, for having no image of me on the screen. I did fight with my camera for half an hour before this webinar, and for some reason I can't get my camera working this morning. It was working absolutely fine yesterday, so I'm not hiding from you. I just can't get my camera working this morning, probably without rebooting. So just going to take you through this webinar, just to give you a very quick introduction to what you're going to see today in this session. So it's not going to be a PowerPoint presentation. It's going to be very much a hands-on type demonstration, looking at MRDCL code and going through some things in some sufficient detail to understand some really, I think, efficient concepts that can really help you get the best out of MRDCL. So I'm going to give you some insight into some of the key features of MRDCL, really focusing on productivity. And what I would like you to come out from this, from people attending the seminar, is to perhaps make you ask questions such as, how can we be more productive? The challenge perhaps from this session is to say, okay, well, he's shown me 4 or 5 or 6 techniques that are interesting, but perhaps only 1 or 2 that are applicable to me. But then perhaps you can look a bit further or think a bit further and perhaps consider other things that you could do more efficiently, because every user of MRDCL is a little bit different. So I'm not going to show you everything there is in MRDCL today. That would be rather ambitious in a 45-minute session. But I'm going to show you, I would argue, probably a mixed selection of different things that can make you more efficient in the way that you use MRDCL. So I'm just going to close this screen. There's no more PowerPoint. It really is straight in with the code and looking at MRDCL scripts for the whole of the rest of this session. I'm going to pause after each. You can see here in my folders I've got 5 examples I'm going to run through. I'm going to pause after each of those sections, or actually 4 and 5 actually go together, but I'm going to pause after the first 3 and invite any questions. If you think of anything while I'm presenting, Charlotte will spot those in the Q&A box, as you just mentioned, and I'll attempt to answer them. Now, MRDCL is quite a difficult topic, if you like, to do live on a broadcast like this. Some of the questions that come in sometimes cannot be answered in just 1 or 2 minutes, and if that's the case, I would encourage you to send a separate email to Charlotte after this event, and we'll either prepare a video or conduct something with you one-to-one online subsequent to this webinar. So some questions I'll try and I'll answer questions where I can answer them in 1 to 2 minutes, but if there's some questions, by the very nature of MRDCL, can sometimes take 10 minutes to answer or 15 minutes to answer, and I really obviously can't do that in a short session like this. So the first thing I'm going to look at, for example 1, is big runs. Now, it's something we get questions on at our support desk on handling big runs efficiently, and so I was just going to give you 1 or 2 examples of things that you can do to make run times a little bit shorter. Now, this is again not an exhaustive list of things. There is actually a blog article on our website which talks about things you can do to make big runs a lot faster. I'm going to cover 2 topics during this webinar. I think it's the first and the 3rd or 4th items on the agenda today. But I'm just going to have a little talk about big runs and ones where the runtime starts to become significant. Clearly, when you're running an MRDCL script and it produces a number of tables, whether it takes 1 second, 5 seconds, or 10 seconds really doesn't matter very much. But it can start to matter if that creeps up to 10 minutes or an hour or 2 hours. Then efficiency becomes much more of an important issue. So I'm going to take you through an example here, and I'm going to open up this script. And it's very much a fabricated script, this, to explain something rather than one you would really use. It's just to look at, it's just a fake project, if you like, to make something that's quite big. And if you look at this line of code here, you'll see what I'm doing is I've got a call to a list of data files. So this is a technique for having a list of data files. And I rather cheat in here, that I'll admit to cheating quite a lot on this example. It really is for illustrative purposes only, and I'm calling in the same file 10 times so that I'm actually processing a lot of records. I think this file data.ask has 2,000 records, and I'm just reading that file 10 times, so I've got the equivalent of 20,000 records in this run. I could have done it some other way, of course, but I'm just trying to knock a project out here together that illustrates handling a relatively big project. And you can see here what I've done. I've got a variable at the top that I'm looping round 200 times, and I'm making 200 variables called QQ1 to QQ200, all of which are dummy defined as 9,999 bits in them. Now, those who are not so familiar with the preprocessor could probably understand that a lot more easily, that it's going to produce code looking like that. Although I haven't compiled it yet, it won't have the X on the front in a minute. So it's going to produce a whole load of variables for me automatically. And then it's going to produce 400 variables called Q1 to Q400. It's actually picking up the same data of codes 1 to 200, 400 times. Again, I'm just doing that for illustrative purposes so that I've got a project which has got 200 big variables at the top here and 400 fairly big ones of 200 responses each. And then when I come down to the tables, I'm producing 400 tables where I analyze each question by itself. So a fairly meaningless table again, but again, I'm using this for illustrative purposes. So the first thing I'm going to do is run this, and it's quite a big run. So if I run it, you'll see it's reading up my 10 data files, which are actually the same file 10 times, but that's getting me up to 20,000 records. It's reading this, and eventually we'll get through to 20,000 records. Here it goes. And it's going to take 8 passes over the data to produce the tables, that are those 400 tables that I specified. And you can see those clicking through now. And it's producing 400 pages of output. And if we look at those tables, they aren't the most interesting tables, but they did originally start with 200 rows by 200 columns. I've actually suppressed all the blank columns and the blank rows so that we end up with this table, which is, again, a meaningless table, but it's just to illustrate producing a relatively large number of pages from a large number of records. Now that run, if we look at the log here, ended at 9:07 and 54 seconds, and it started at 9:07 and 18 seconds. So by arithmetic, that took about 36 seconds to run. And the reason I want to show you this is I've actually here got a big variable, 200 of them, of 9,999 responses. If I put an X on the front of that, that would make it a temporary variable, because I'm not actually going to use this variable anywhere. You can see it's a sort of redundant variable. In a real run, this might be used as a building block for Q1 to Q400, but it's not. It's just an example. And if I just make it a temporary variable, that's going to make a significant difference to my run times. If I run it again now, I think it ran in 36 seconds just now. I'm running it again. Just by making redundant variables temporary that I don't need, it should run this in probably about half the time, if I'm going to estimate correctly. There's my tables. It ended at 9:20. It started at 9:06. So it ran it about in 14 seconds. So just under half, about 40% of the runtime. So what this is trying to illustrate is, if you've got variables that you don't need for tabulation, put an X on the front, and MRDCL will treat them as a temporary variable, and you will speed up your run. So just by making some redundant variables temporary, this ran 2.5 times more quickly. Now, the other technique that I think is important with a big run is that it's very easy when, this is obviously not a very good example of a real run, but if you've got a long script with lots of variables in it and lots of different tables in it, the chances of you making an error obviously increase. The more code you've got, the more chances you're going to make an error. And it's not uncommon that you have to run this many times. And each time you run it, you're going to be reading the data, and then you're going to be incrementing the tables. Now, again, here, if you've got a project of this sort of size that you're going to run continuously, or if it's bigger and it starts to take, an hour to run or 20, 30 minutes to run, I would always recommend splitting your STP files so that, let's just copy this file here to another name, copy and paste it, and rename that as run2, and edit run2. And what I'm going to do with this is take out the tables so that all that this run has is my data stage effectively. And I'm going to open up another run called run2_tables and create that file and paste back in those tables into a separate script. And if I just put in some control at the top, start control, tell it that this is coming from the run called run2, and finish control. And now I have what's called a split setup, in that my data stage is in one file and my table stage is in another. And now what I can do, I can run run2 as a separate entity, and that will run at the speed as it did before, or not much less. But now the real advantage that I get is that my tables are in a separate run, and however many times I run these, they will run much more quickly. So here we go, it's just going to run those tables. So if I wanted to add tables or change tables, I could just run the tables there in, 1204, in about 7 seconds. So again, I've actually reduced, 9 seconds. So I've actually reduced the runtime even further. And if I had just one extra table that I wanted, I've got a run here called extra table, where it's just picking off one extra table, it would run that almost instantly. There we go. So if I just want one extra table from this same project, it ran that in probably less than a second. So splitting your setups when you've got a big project is something that I would recommend. So that's just a very quick introduction to handling big projects, and there is a blog article on that. I'll just pause there briefly in case Charlotte's got any questions that anyone's entered on big projects from example 1.
Yeah, we've just got a couple come in. Okay. I've got here, do big single variables matter? What about integers and W variables?
Okay, that's a good question. They do matter, but not anything like as much as a multi. A big multi-response variable, like the one I had there of 9,999 responses, or if it had even been 1,000 responses, takes up a lot more space and takes a lot more time to process than a single. When it's a single variable, it's effectively handling that like a number, and so it's very efficient. So say you've got 10 regions and it's a respondent is the 9th region, it's holding that in the program as number 9. If it's a multi-response variable, it's being prepared to have all those values true or false, and so it takes up a lot more space. So multis are the biggest problem. And the second part of the question was about integers and W variables, was it?
Yeah, that's right.
Yeah, W variables are a bit slower than integers, but unless you had lots of them, not enough to make a difference. I tend not to worry about those, and in a sense, you need them as well when you need them. You don't tend to have many of those per project, so they're less of an issue. But yes, avoiding unnecessary multiples being written to the IDF or being not made temporary is important.
Okay, thank you. Yeah, we've got another one. So why is it faster to run from an IDF?
Okay, I probably didn't explain that very well. What we're doing with the split setup, if we go back to run 2 here, this is doing everything in one run. So what it's effectively doing is it's compiling my script, it's reading up the 10 data files in this case, and reading all 20,000 records, and it writes them to what's called an IDF. So that IDF is built, and then it goes on to run the tables from that IDF. Now, if that's all in one run, every time you're running a table, it's reading the data, building the IDF, and then calculating or incrementing the tables. If you use a split setup, it's going to split that into 2 bits. So when I was doing run 2, as I was here, and split it into 2 setups, it was building the IDF, and then when it come to do my tables, it was just reading from the IDF without actually having to read all the data again. So it's avoiding that need to read the data more than once.
Okay.
I hope that answers the question.
Okay, thank you. Just got one more here. When does a survey become big? Is it 1,000 respondents, 10,000, more?
A good question. The answer I give to that is when you find it slow for you to run. That's not a very good answer. I mean, it's a mix of the 3 main things, which is the size of your IDF, which is comprised of what variables you've got in there. So the more multis you've got, the bigger it will get. Lots of singles won't make too much difference, but if you've got a large number of multis, that will increase the size of the IDF. So that's one factor. The second factor is the number of records you're reading, and the third factor is the number of tables that you're running. They're the 3 main things that are going on. And I guess it's a balance. If one of those is big, so if you're running, let's take one extreme, one table on 500,000 records, and you've only got 2 variables, that would be quite quick because it'll just rattle through the data and produce that one table, even though there's 500,000 of whatever I said. It's when all of those start to creep up, or 2 of those start to become significantly big figures. As to quantifying that, that's quite hard to do. But you know, I had a project here of 20,000 records with 400 variables, and it ran that in less than a minute. Now, if that had been more variables and they were all multis, and that was 100,000 records, and I was doing, you know, 2,000 tables, that starts to get quite big and might start to impinge on run times, and you might want to think about trying to make them more efficient. So a difficult question, which I've not really answered very well, but hopefully that gives you some indication.
That's all the questions for this section. Thank you. Okay,
all right, let's go on to the second example that I've got for you here. Now, many of you, I think, probably already tried or have been introduced to EPS, which stands for Excel Productivity Scripting. And this is just a simple example of where EPS can really help you. So the scenario here is where we've got a tracking study. And if I show you a workbook, I think it'll be fairly easy to explain what it is I'm showing you here. So if we can just open this workbook. So I want you to imagine a tracking study here that's running quarterly, and to keep this one simple, I've just said there's 5 questions on my questionnaire, questions 1, 2, 3, 4, 5, as you can see in the spreadsheet, and we've got 3 quarters of data. Now, we all know what happens with tracking studies, that the client says they're never going to change, and of course every quarter they do change, and normally the data changes with it, questions appear, some questions disappear, and so on. So what this is going to illustrate, this example, is that you can manage all of this in a workbook and use the EPS technique within MRDCL. Now, I'm not going to take you into the depths of how you do this in MRDCL, because that's really a full session on its own. But let's look at this. You can see here I've got 5 questions, and what it's saying at quarter 1, this data was in field 5, this was in field 6, field 7, and field 8. At quarter 2, question 1 didn't exist, so it's blank. Question 2 was therefore in field 5, question 3 was in field 6, question 4 was missing, question 5 was in Q7, and at quarter 3, it jumped around again. It was in 5, 10, 8, and 7 with that question missing. And what's nice about having your data in that sort of form is that if we open up the run here, everything can be automated from that spreadsheet, so that the spreadsheet effectively is controlling the run. So if I run this, it's going to prompt me and ask how many quarters there are. I'm going to type in 3 because we've got 3 quarters, and it's going to run a set of tables for me. And in this case, it's going to put the quarters across the top. And you may recall that question 1 was only in quarter 1 and 3. Question 2 was in all 3 quarters, so was question 3. Question 4 was only in quarter 1, and question 5 was in quarters 2 and 3. So it's automatically done everything for me in terms of picking up the data from different locations in the data map, and it's automatically generated tables and only picked up the quarters that are present. And I can just show you how that might work when you might move to a 4th quarter. So let's add another quarter in now. Let's open up this question manager again. And I can add quarter 4. And for example, I could say that question is in 5, that one's in 7, that one's in 8, and that one's in 10. So question 4 comes back at quarter 4. I can save that and close it and go back to my run, which is over here. I need to just tell it that we've got another data file now for quarter 4. Just trying to see how that's done. Let's have a quick look. Okay, data files.txt, I couldn't see it. Okay, so that's now calling in the 4th data file. And now if I run with a bit of luck, tell it it's 4 quarters, without changing any script in MRDCL, I've now got my 4th quarter coming in, and you can see quarter 4 has been added where it's appropriate. There's it, and it's not come up at question 5 because it's not in question 5. And indeed, that spreadsheet could go one step further. I don't want this to take so long to open this, but it is. And I could add in another rating scale, Q6, a new rating scale, which perhaps came in at this wave at quarter 4, not question 4, quarter 4. And I could run this again now, 4 quarters. And with a bit of luck, if I go to the last table, you can see I've got a new rating scale automatically come out for quarter 4. So what this is showing you is EPS in action and how you can automate things from a spreadsheet, so that the script that reads that is quite complex. So that's the script that's reading it. It looks more difficult than it is. The way I prepare these scripts when I'm using them is typically to actually just put in the code for one question and then substitute what I want here. So although this looks quite difficult, if that started as question 1, for example, which is what I would want, I can then change question 1 to be db1.question, which is the name of that field in the data file. I can just quickly show you that. Again, here we go. So that's referring to that field there. So I do it by substitution so that it reads this spreadsheet for me, but then the whole thing is automated. And if your questionnaire changes from wave to wave, you're doing it, it becomes a clerical task that somebody who doesn't understand MRDCL even can manage the project from here. And I can extend that a little bit further. I've got a slightly extended version of that. Just let me close some files here because I'm getting too many things open on my screen. I've got a slightly extended version of that that might be useful. Every question there in my example had the responses very good to very poor. You may not have noticed that in my tables, but they did. And what this illustrates is that you can extend this a little bit further. So if I go back to the question manager on this example, it's pretty much the same thing. But you can see I've added a feature in here now for this one where it's been extended to say, well, the labels for question 1 is the rating scale good to poor, question 2 is good to poor, 3 is satisfied to dissatisfied, and so on. So I'm adding another control in here to say what responses are appropriate to that particular question. And if I run that now, and I didn't notice it's only for 3 quarters. Let me run that again. Run it for 3 quarters. It's not set up for the 4th. And you can see now that question 1 has very good to very poor. Question 2 has the same, but 3 has very satisfied. So these spreadsheets can control all sorts of things. It's not just the data. Anything you like about these anything you want to control about these questions can be controlled. You could have different scoring systems. So I could have put in there that I wanted very good to very poor to score +2 to -2, and very satisfied to very dissatisfied scored 5 to 1 for some reason, and that could have gone in there as another control in the worksheet. So that's an example of using EPS to handle a tracking study. There's lots of other uses of EPS. EPS is all about having a problem and putting it into a spreadsheet as a template so that a script can read that, and you don't change the script, you just change the Excel template to automate what it is you want to automate. I do have another short example of that at the end. I'll pause briefly. Any questions on that section, Charlotte?
Yeah, sorry, just didn't get to unmute there. Okay, I've just got a couple come in here. The first one is, would this technique work for a tracking study where you have meal occasions over 2 weeks?
Oh, that's a big answer. How can I answer that? Yes, it would. There's actually a second technique for handling meal occasions, which I really can't go into in this webinar. If anybody if the person who's posted that wants to email myself or Charlotte afterwards, we'll happily give you an example of that. What you do with meal occasions is, rather than write a variable for every, so say you're asking people about up to 10 meal occasions over a week, so potentially 70 meal occasions, you wouldn't write 70 times the number of variables to process that. You have a technique which allows you to pick up each occasion as an occasion, but each of those 70 possible occasions and write it as an occasion record. It uses another technique on top of what I've shown you here. So yes is the answer, that you could use this technique, but you'd add another technique to it to process the data in an effective way. So I didn't give a very good answer there, but yes, it would be. It has some brilliant tools for doing that sort of thing. MRDCL is probably what I should be saying. Any more?
Thank you. Just one, yeah. Can someone just ask if you can show how you added different text for each question again?
I cheated a bit and didn't show. I mean, all I've done here is that I've extended the workbook or the worksheet. If I can open this. So I've added an extra field into the worksheet so that I can say what text I want for each question. So if I change this to good-poor, this one would now get good-poor. And if I added a question 6, I could use satisfaction or good-poor or any other ones that I've got set up. What's going on behind the scenes there, which I didn't show you and I concealed from you, was that you can see there's a chunk of code here that says if it's not good-poor, or if I want these labels only when it's good poor. So it's going to pick up those labels when the good poor text is found in the worksheet, and it's going to pick up the sat text, which actually is scored differently automatically when it picks up the dissat in that worksheet. So you can branch round this and just pick up. So if I wanted another rating scale, which was let's say happy to unhappy, I can't think of why I want that, but let's say happy - unhappy, I could then do the same thing with that and change that to happy. You can see what I'm doing here, but you can see what I'm doing, just quickly changing these things. And now I could call in happy to unhappy here as a new type of thing. I've done that very quickly on the fly. I hope I've done it right. 3/4. I've clicked the wrong button in my haste. 3/4. And with a bit of luck, I think it was question 4, I've made unhappy to happy now and enabled that as a way of scoring. I didn't change neither good nor poor correctly, but you can see what I've done roughly. So yes, anything you want to control, you can control that way.
Okay, I've got one more thing just to show again here. They said, sorry if I've missed it. How can we make the STP file read that question manager Excel file? Okay,
very good question. Fairly easily, you use a call to open the workbook. So there's a command called dbopen. you give the workbook a name. I've given mine the name DBXLS. You could call it XLS, you could call it A, you could call it your name, anything you like. So you call a reference to open it, and at the bottom you call a reference to close it. And once you've opened that, and that can have a path as well, so it could be on a server, you could say Z:\/ or something like that. Then once you've done that, you can loop through that worksheet or workbook. So that's telling it to loop through the workbook or open the workbook called question manager.xlss, access the worksheet called control, which is what I was in just now. I'll open it once more. So it's telling it to, here we go, there's the worksheet name control. So that DB loop is saying open up the workbook called question manager.xls, go to the worksheet called worksheet, and then loop through that from the top to the bottom. And then in here, I've got more normal looking preprocessor code that's picking off different things. After this, I haven't got time to go through that in detail at the moment, but that's the principles. Whereas we normally just send out recordings of the videos afterwards, we'll actually send out the scripts for this one as well, so that you can have a look through them yourself. But if you still want more help with any of these things, we'll be happy to do a one-to-one session with you, or send a video that shows you what you want to see. Okay to go on?
Yeah, that's all the questions for this section. Thank you.
Oh, okay, good. All right, I managed to close something I didn't mean to close. Just give me 1 minute. Webinar. Okay, the third one's quite a quick example. It's another one to do with efficiency of runs. If I quickly take you through this script, I didn't mean to run it, through this script, I want to just draw your attention to something you can do here. So what we got here is a very simple script that picks up gender and age, and then a reference to, this time, a CSV file, not a workbook. We could have done it through a workbook. This is just using a different technique. So if we open up the workbook hourlypay.csv, you can see that it's actually just got some random data in here. It's saying, here's the respondents in my survey, 2,000 of them, and this is the hourly rate of pay they get, 22, I don't know what currency it is even, but let's call it dollars for the sake of argument. So respondent 1 earns $22, respondent 2 earns $12, and so on. And these are just random numbers actually, but it'll suffice for this. And what we want to do is to pull that data in with our survey data. So we have this data externally. Now, one common way of doing this is to use if statements. So I'm just going to quickly edit this because I left this in the wrong state. So I quickly edit this. So this is a common sort of way to do it, is to say, okay, I'm going to call that CSV file data 100. And I'm going to count the number of cells in data 100. So if we look at it, was it 2001 lines long, and it's 2 columns wide, so it's got 4,002 cells in it. And I'm going to loop round here from 3, and the count was, if I remember rightly, 4,002 in steps of 2. And so what it's going to do, it's going to say, if the serial number is the first item in here, I'm starting at 3 because they're 1 and 2. If the serial number is 1, I want to set the hourly rate to 22. If the serial number is 2, I want to set the hourly rate to 12. Now that all works, and if we run that, I got the right thing open here. Yeah. No, I haven't got the right thing open. I've got it open. Let's just shut that. Never do these things live. Okay, if I run that and we look at my listing file, you can see what it's done for me. It's actually generated all this script for me from that CSV file effectively, and I'm setting the hourly pay. So at the bottom here, I could put people into some bands for hourly pay. So I'm grouping people as $10 to $12, 13 to 15, 16 to 20, greater than 20. And sure enough, at the end of my table, at the end here, I'm getting a table of their bands with a mean score and split by males and females, and the females earned more than the males in this particular sample, and then by age group I'm getting that data. Now that all works absolutely fine. There's no reason for not doing that. The only thing that can be a problem with that is, again, size, is that one of the most inefficient things in MRDCL are if statements, and I have seen people pick up sort of like 100 fields for 50,000 or 100,000 respondents, and then ended up with 1 million if statements, which really do slow the run down. So I'm going to quickly show you another technique that you can use that does the same thing. So if I just put a skip around this, skip 100 means just ignore everything until I get to statement 100. So that's going to ignore that now. And if I take this skip off, here's method 2 that I'm using. Now this looks a lot more cumbersome, but actually it produces much more slick and fast code. First of all, I pick up a list of all the respondent IDs, which is coming from the cells in the spreadsheet. So if we remind ourselves here, it's going to pick up all these respondent numbers. So it's going to pick up 1, 2, 3. Now, as it happens, they are sequential, but I've done this in case they're not sequential. I know we know they are on this occasion. So it's going to pick up 1, 2, 3, 4, 5, 6, 7 up to 2000. And then I've got this technique where I say, define the integer hourly pay as being the value matching that item in the list. Now, if we look at that in the listing, let's compile this and look at it in the listing file. It becomes a lot easier to read. So let's save that and run it once more. Close that. And it'll produce exactly the same answers, but let's look at the listing file. So now I've got a variable called resp IDs, which is just a long list of numbers all the way up to 2000. But you can see what it's generated here. It's saying, okay, the hourly pay is resp IDs bracket, and it just assigning it one for one. So the first one in this list is the first respondent, the second is 12, the third is 22, the fourth is 12, the fifth is 24. And so what it's doing now is it's assigning it based on the responses in that variable, and that is much more efficient code. And so I did have somebody having a slow run not too long ago who had over 1 million if statements. We converted it to something like this, and I think it converted the run from, I don't know, a few hours down to about less than a minute to run, which was extraordinary. They didn't believe that I could do it, but that's the technique that I used to do that. So that's just another way of doing things, and a much more efficient way of picking up lists of numbers or codes that you want to assign to data that you're pulling in from Excel, a CSV file, a data statement, or from an Access file, any of those things. Any questions on that, or is that all pretty much self-contained?
Just got one here that said, could you use this to import clusters from SPSS?
Yes, I'm not an expert on SPSS, but I'm pretty sure that you can get the clusters for each respondent into a spreadsheet type form. I can't remember how you do that because I'm not a user of SPSS very often. But you could just use exactly that technique. So if these were clusters, so if the first respondent was in cluster 1 and this one was in cluster 2 and this one was in cluster 5, that would be the sort of technique that you would use. I'll quit that here, but you could do all that via a spreadsheet using almost identical code to what I've done. So whereas I'm pulling in the hourly pay for each of the respondents, for each of the 2000 respondents, you could do the same thing for each of the clusters that they fell into, and it would work absolutely fine. It's a very good use of it, in fact, and I know plenty of clients that do that.
Okay,
anything else?
That's all. No, that's all for that section. Thank you.
All right, now we're going to finish with 3 examples that sort of link in together here. So I'm going to do quite a lot in one section here for the last technique I'm going to show you. So let's go to example 4. As I say, all these scripts will be sent to you after the webinar by tomorrow. So, and let's have a look at this one and see what it does. So let's open up this script and let's just have it. Oh, I didn't mean to run it. I meant to look at it. So what we've got here is a rating scale, and What I want to talk about here is different ways of doing summary mean scores and generally managing figures in tables, because there's some techniques that you can use which do two things really. There's efficiencies versus inefficiencies, but also some control that you have to actually control what happens to your tables a little bit more. And there might be some techniques here I think that probably a lot of people haven't seen. So let's just work through the tables that this run produces first of all, and then sort of examine what it is I'm doing. So just as an introduction to it, quite a simple example. We've got 4 questions. They're all rating statements. To pick that data up, I'm looping through it from 1 to 4. I'm picking up those questions 1 to 4. And down here, I'm doing something that is actually pretty much the same as I was doing in the last example. To an integer, I'm assigning the score as well. So here you can see for very good, I'm assigning a value of 5 in the value statement here, and the quite good 4, the not so good, well, neither good 3 and 2 and 1, and excluding not stated. Here I'm actually putting it to an integer as an alternative. So what I'm saying here is that the value in IQ1 to IQ4 will match the code, just like I did just now when I was picking up those hourly rates, so that the first code gets a value of 5, the second 4, 3, 2, 1, and that U means undefined, which means it's a null value and excluded from any calculations. So that's what I'm doing, picking up those variables in sort of 2 ways, one as responses and one as a score. And down here I've got 2 very simple variables, which are just gender and city. So let's just run these tables and just inspect them one by one and look at how they were achieved. So if we look at the first table, what I've got here is a summary of mean score, something you quite typically want. So we're getting a mean score of 3.8 here, 3.4 for London, 4.2 for New York, 3.8 for Bangkok, and so on for 4 rating scales. Let's look at how I've done that. So when we go down to the tables, you can see that I've got a loop here of 4 things. I probably just, sorry, one thing I should have probably done was just to show you that script in the listing file in the longhand. So there's Q1, there's IQ1, there's Q2, IQ2, Q3, IQ4, and now we're on to the script that we're looking at in the table stage. So sorry, I jumped a bit too far ahead there. So this is method 1 that we're looking at, which is table 1. And you can see I'm looping around the 4 questions. I'm picking up the label for mean score from 1.a, so that's data statement 1. That's what we saw there with the list of the 4 rating statements. And I've got this fairly heavy bit of code here. Oops, I meant to highlight that much, which says skip over the plus sign when it's equal to 1. So for the first table, I don't want the plus sign because plus means put it on the bottom of the previous table. But for the second, third, and fourth ratings, I want them on the same underneath the first one, so they look like one table, as we saw when we looked at the table just now. And that's putting that into table 1A, B, C, and D. I'm a little bit lazy. I've used the format option NAID so that the table 1A will come out as 1. And I'm using the format option NDIS here, which means don't show the distribution. So if I put that back on, the table that I would get would be all the distribution showing. And there you go. You would see I'd get the distribution with the mean score, the distribution for the next one with the mean score, and so on. But I don't want that. I just want the just want the mean score. So I'm putting an N on the front of that, and that's stopping the distribution coming out, and it's producing Q1, Q2, Q3, Q4 by city. Now, the inefficiency in that particular piece of script is that actually the program's wasting its time. When I took the N off that and it came out with dis, you saw it was wasting its time, produce all those rows with very good to very poor, which is just wasting its time because what it effectively it's doing is calculating all of that information and then just hiding it from you. So it's doing all the work and then it's just hiding it. So it is wasting its processing time. Now, on a small script like this, it doesn't matter. But if we had hundreds of mean score tables, that would start to impact. You'll start to get a slower run. Let's look at method 2, because that produces exactly the same table. If we go down to question 2, table 2, it produced, oh, I haven't rerun it, so let me rerun it quickly. Okay, oh no, I haven't saved it. One moment. I put NDIS back on, but I didn't save it. Let's try again. Okay, so now we've got back to table 1 as it was, and table 2 is exactly the same table, but I've just done it a different way. So let's look at what's different about table 2 and see why that's a little bit more efficient. So let's go back to our script and let's see how I've done that. Now, I've done that one rather than using NDIS, so it hides all the rows, so it calculates all the rows and then actually just hides them. I'm using the actual score here that I put into the IQ variable. So you remember here, I produced a variable for each question called IQ1234, where it stored the value. This is a bit more efficient, and the way that you call that is by the @ symbol there, and you call the IQ variable that's got the actual integer value. And that, I can't show it here because it's too small a project, but that would be a more efficient way than method 1 of producing the same table. Now I'm going to show you a more complex way but has a lot more potential as a third way of doing this. If we look at our tables here, you'll see the third table is going to give you slightly different answers. Now, the reason it's different is you'll see I've got a 3 and a 3y here, because what I'm going to do, I'm going to produce a table now which gives me a sum of the scores and another table which gives me the number of people who go into that score, and then we're going to divide one by the other to get the mean score, which of course is what a mean score is. So what we're doing here in this table, these are the sum of the scores for the people who, in London, that's the sum of the scores for the 12 people in London. 41 is the sum, and that was comprised of 12 people. And of course, the table we really want is 41 divided by 12, which is, I think, probably 3.4 if I go back and look and cheat at the previous table. So in this example, I'm actually producing 2 tables to do my calculation. The first one is giving me the sum of the scores, and the second one is the number of people answering that. I obviously still need to divide this table at the top here by this one to get the correct figures on my tables. But let's have a look at how I achieve that first. Now, it looks a lot more cumbersome, but you'll see some benefits as we go through 2 or 3 more examples in a minute. So first of all, I'm defining a variable called rows, which is picking up those labels in data statement 1, which, if you remember at the top here, were these pieces of text here. So there they are. I've got a variable called rows, which is picking up the 4 statements. So now I'm going to just treat it like one table rather than picking it up here. If we look at our listing file for 1A, you'll see it's effectively making 4 tables and putting them together as one. At table 2, it's putting them as 4 tables, putting them together as one. In this example, I'm going to generate just one table and do all my calculations within the table. So the first thing I'm going to do is to get a base row. I'm going to say that table 3 is star times city. So that will give me the base row of the number of people in total in London, New York, and Bangkok. And then I'm going to plus on underneath that a table called 3x. I'm not going to increment it, so that means not increment the table. So if I just run it with that line, I'll get an empty table. I don't want vertical percentages. I want 1 decimal place of my mean scores, but I'm effectively setting up a table here, which is just empty rows down the side, because that's what that means there. Set me up 4 empty rows with city across the top. So as it stands at the moment, I'm getting an empty table with rows and city. And then table 3, while I'm not incrementing as well, which is also rows by city, because I'm going to use that for the bases. Now, if I just comment out what I've got down here and run that, you'll now see that table 3 comes out as an empty table. So there we are. What I've got at the moment is just the sort of shape of the table, but empty. So how do we get the figures that I had just now in there? Let's locate table 3. Here we are. So I can uncomment these 2 lines. So I do this by saying I want to select IQ1 as being the value that I weight it by for row 1. So if we look at that in the listing file, it'll be a little bit easier to read. So here we are in the listing file. What I'm getting, they're uncommented now, of course. I'm getting select WQ IQ1, so that's the value, and putting that into row 1 of my table, which is question 1. In table 3Y, I'm finding how many people gave an answer to that. And then on the second row of the table, I'm incrementing by the score at IQ2, and so on for 3 and 4. So now my table is a 3x. 3x is the sum of the scores, and 3y is the people answering it. So if I run that now, I think I need to save it, that's all. We're back to where I was at the beginning, and now my table 3, this is the sum of the scores, and that's the respondents going into that. And I've now got to divide one by the other to get my mean score. And all I've got to activate now is this line of code here, which says table 3x is table 3x divided by 3y, and that will give me my mean score. And if we now go to table 3, you can see I've got exactly the same answers as before, but done a completely different way using a completely different technique. I don't want table 3y anymore. It was only used in calculations, so we can do some tidying up there as well. I can put in here a format option saying not print table, so that now the whole thing is a lot tidier and it looks just like the other tables with the scores and not that table used in calculation only appearing. Now you might be saying, why do it that way when it looks a lot more complicated? Well, it's about control, and if you've got lots of mean score tables or you want to do any post processes on the tables, you'll start to find this a better way. Now, what do I mean by a post process on a table? Let's say for table 4, I want to suppress any bases that are less than 10. So let's go to this table. It's the same for 1, 2, and 3. But let's say I don't want to show bases of less than 10 because it might identify respondents. That's certainly a very common thing in employee surveys that you do. You don't want bases of 1 and 2 because it could identify an individual employee's opinion, for example. So what I want to see is all the columns on here where the base is 10 or more, sorry, it's greater than 10, but I want to hide Bangkok because there's only 6 people in there. Now, I can't do that with the first 2 examples very easily, but with this example, I'm in full control of the figures on the table. So this is just a repeat of table 3 above. What I'm doing down the bottom here now is actually applying some control. So now this is going to set it to be the same as table 4. So as things stand, 4 is exactly the same as 3 at the moment. I think we've got MPTB on that one. No, we haven't. So 4Y ought to have NPTB on it just to make it the same. I think if we run now, table 4 should just look like table 3, be yet another version of it. So it is just another version of it. But let's say we want to suppress those people in Bangkok because there's too few of them. What I can do is I can do something that I always think looks a little bit strange, but I can actually go through all the 3 columns on my tables, the London, New York, and Bangkok columns, and look at the sample size in that particular table. So I can say, well, let's pick up into an integer. So you can define integers in the manip stage. A lot of people don't even know that, but you can define integers in the manip stage. And you can say that comes from table 4, row 0, and I want to pick up column 1 first of all, then 2, then 3. And then I'm going to say, if the variable sample size is less than 10, set it to 0. So what it's going to do on this particular table it's going to look at the sample size in table 4 and say, okay, is this sample size less than 10? No, it's not. I'm going to leave it alone. Is this one less than 10? No, I'll leave it alone. Is this one less than 10? Yes. I'm going to set it all to 0 and suppress it when it's 0. So I do that in 2 steps. I first of all say if it's less than 10, make that whole column set to 0. And I also use a format option up here called BCS, which says blank column suppression. So now Bangkok has been set to 0 if it's less than 10, which it is. And with a bit of luck, when I go to table 4 now, you'll see that Bangkok has disappeared because the base was less than 10. So that's one reason for doing tables that way. Another reason is you've got lots of big tables with lots of calculations. It can be a very efficient way of running script. The other technique I'm going to quickly cover in here is ranking mean scores. There is a technique here for rank mean scores where there's a format option. So this is using the same technique as we used at table 1 using NDIS. But if you put RNS2 before it and RNS0 after it, it will rank the mean scores for you. So if we look at table 5, you'll see that the mean scores have been ranked in order. I think just 3 and 4 switch round. 1 and 2 are the highest, but you can see 4's come above 3. And we can also replicate that using the method we used at tables 3 and 4, where we're doing our own calculations. And I can use the label controls G1B and G1E so that they're automatically ranked. And so table 6 has been handled like table 3 and 4 and produces the same thing, except the manip actually has not been activated yet. I need to just uncomment a line of code somewhere. Yes, that one there has not been uncommented. So if I run it now, we should get that ranked correctly now. And so it is correctly ranked using the second method that I showed you. So there's some good reasons for doing mean scores or considering doing mean scores in those 2 ways. I'm just going to finish with one other thing. You may think that second way I showed you of doing mean scores by calculating 2 tables divided by the one by the other is a difficult approach. What we can do here is we can what's called parameterize that. So what we can do things like this. We can say that, okay, here's my data statement with questions 1, 2, 3, and 4. Build a piece of code that just uses what I'd done then that was quite complex. So if we look at meantab code.stp, you'll see it looks very like what I was showing you just now, but it's been converted to have parameters in it. So it's picking up things like meantab.1, meantab.3, and so on. But it's basically the same code as I showed you just now, dividing one by the other. And what we're doing to make that work is we're saying, well, what are the parameters that drive that piece of code? Well, the first parameter is the data statement number, which lists the questions that I want. So that's data statement 10. So that's matching that 10 there, which is going to pick up questions 1, 2, 3, and 4. The 3 is the table number that I want. And what I want across the top is city. And so by defining those 3 parameters, that's going to drive the function meantab code.stp, and it will produce the table that I want. So it's now produced Q3 with rather reduced labels, Q1, 2, 3, 4 here, but produce the same figures using parameters. And if I wanted to extend that to, I've got questions 5, 6, and 7 here, I could say data 12 is question 2. Let's pick question 2, question 5, and question 7 in a table. I could say that star data mean tab is using data statement 12. We'll call it table 99 and we'll analyze it by gender this time. And then we'll insert mean tab code. So rather than having to use that complex code that I was showing you just now, we can have a function called mean tab code that we just call, feed it some parameters, and it'll automatically do my mean score table in a far more efficient way. So if I run that now, I've got a second table which has got questions 2, 5, and 7 down the bottom. You might say these look the same as questions 1, 2, and 3, and you'll be absolutely right. It's the data here that's not real data. It's just replicated the data, but believe me, they are different variables that are coming out and producing different results. Just to finally, before I stop, because I realise I'm slightly overrunning on this webinar, I did plan to finish by 10. I've got one bonus example here, which goes one step further and sort of combines that technique together with using EPS. And this is something that actually I developed with a client. A very quick story. A client came to me once and said, when we have rating scales, there's about 15 table types that we sometimes want for a rating scale. And they described them as the ratings, a table for each item in the rating scale, a summary of mean scores, a summary of each rating scale side by side, a top 2 box, a top 2 box, and a bottom 2 box. You name it, they come up with all the examples. And what we designed was a slightly more complex version of this, but not particularly, just more code. And we said, okay, let's put that into a spreadsheet so that we've got in here what the scale's called. That's the title, that's the data location. The step is what seeks the columns are in, so 11, 12, 13. The list of brands or whatever it is that are being rated are in a worksheet called list 1 down here. So there they are, brand A, B, X, D, and E, whereas list 2 is A, B, B, C, C, D, E, D, D, and E, and F. The text, rather like the example I showed you earlier, was very good to very poor, or agree strongly to disagree strongly. The banner we wanted was gender and age. And here we just have check boxes saying which tables we want. Now, we've only got 4 in here, but we've got a top 2 box added, a top 2 and a bottom 2 box added for these ones, a summary table of some sort, and another type of summary table here. The list could go on all the way across the page. All that the person has to do to produce the tables they want is literally fill in this worksheet, check off what types of tables they want from their rating statements, and they come out automatically. So let me just show you that running. It's called EPS example, I think. So let's just run that. And sure enough, I've got 17 tables out, and you can see it's not very interesting data. I've got a top 2 box and for the brand A, then a top 2 box for brand B, a top 2 box for brand X, D, E. And then I go on to the next statement, which is brand AA, and that's got a top 2 box and a bottom 2 box. And that's just doing what it's told here, basically. And so if I wanted to have a top 2 box table on this one and a bottom 2 and a summary table, I can just check those things off. I can take that off and add that on. And without changing a line of MRDCL script, it will now produce something completely different. Let's close it. Let's run it again. And now we've got something different. So we've still got the top box table. With a bit of luck now, we get a top 2 box and a bottom 2 box table because I've checked that one. And we now get a summary out as well. I don't know what the summary looks like offhand, but here it is. Oh, it's a bit like the table we've done just now. That could be a ranked or an unranked summary. But basically, all these tables are being driven by X's in this spreadsheet. And so if you had all the different permutations you want set up, you could put this template on your server and all of your staff anywhere in the world could access this and use this template to pull off the tables without writing a single line of code. And this obviously offers real power. Doesn't just apply to rating statements, anything at all that you can think of that could be put into a template where you can check things off, you can do it. It's really down to your inventiveness. And if you've got some ideas that you want to bounce off us and see whether we think there's a good way of doing it, we'll be more than happy to help you. I'm going to stop there because I know I've already overrun by 3 minutes, and I'm sure there'll be 1 or 2 questions. I'll try and field those as quick as I can. If there's sufficient interest, I'm happy to do a session training people how to use EPS. There are going to be a series of new videos training people how to actually do this stuff coming out in the next month or so. But I'll stop there because I'm already aware I'm overrun. Any questions, Charlotte?
Yeah, there's a couple. This one was asked about 10 minutes ago. It was, will the values be retained if it is in the percentage view?
Will the value? I'm not sure I understand the question, unfortunately.
It was asked about 10 minutes ago. Perhaps we can find out exactly what it was and come back to that. I can email that answer out.
Okay, sorry, I'm not. Yeah, I'm not quite sure what when that was referring to and what it was. Sorry about that. Please email us afterwards, and I'll certainly answer that one later.
There is another one. Are the EPS and other method application for multi-answer questions?
You can use EPS wherever you like. EPS is a technique. It's an interesting technique. I find sometimes the people who are best at using MRDCL or the cleverest at using MRDCL aren't the best people at thinking where EPS comes in. But really, EPS is a way where if you can think of a way of controlling something through parameters or keywords on a spreadsheet, or in this case is X's. This one's controlled by X's here and by some keywords like these. If you can think of a way that certain things that you want to do, whether that's managing data, automating open-ended code backcoding, handling subtotals, singles, multivariables, assigning values, anything you can think of, there's usually a way of putting that into a template so that you can reuse it from project to project efficiently. So yes, it would work with multivariables absolutely perfectly, yeah.
Okay, just got one more here then to close up, and it is, can functions be used to define variables as well as tables?
Yes, absolutely. Yes. I've given you an example here of where a function you can feed it some parameters, and that feeds those parameters to a piece of code. The way you use functions is like the example I just showed you. No, not that one. I think here it is down here. Have I got the right one open? No, I haven't got the right one open anymore. No, I haven't got it open. I've shut it. But they're done by setting parameters in a data statement and then calling a function that applies them. So they could apply to variables as well. So you could, if you wanted a quick way to pick up a whole series of rating statements, you could do that, or assigning values, you could do that. Anything, yeah, yes is the answer. You're on mute, Charlotte.
Yeah, that's all of our questions we've got today.
Okay, I think then we'll close on that, shall we, Charlotte?
Yeah.
And as I say, we'll send out the scripts used in this presentation today, as well as a link to the video of it, so that you can both follow the actual webinar itself again if you want to, or share it with colleagues, but also have the scripts that we use today. So thank you everyone for attending. I'm sorry I overran by 5 minutes there. I thought I timed it perfectly, but I clearly didn't. Thanks very much for attending, everyone, and hope to see you all again soon.